says degree and hit enter. And then you can clear to get out of there, or mine's X. So I'm going to do 5 times the tangent of 45 degrees. What'd y'all get?
5.
Yes, you should get 5. All right.
Why does it say like 8 point something something on the other when it's not on the sheet?
Because that's in radians. So it's like measuring something in centimeters versus inches. It's just a different way of measuring things. We're going to talk about radians in here, just not yet. So on the next one, it says if AC equals 5, I have to get out of here. Get back in. Next one says if AC is 5, find the length of AB. So AC, we just found, was 5. So I'm pretending I don't have this other stuff. And we're looking for AB. So I'm going to call this Y. So same angle, still angle B, because that's the angle I know, it's 45. I have the opposite side, and what's Y? Hypotenuse. So which trig identity has, not identity, trig function has opposite and hypotenuse? Sine. Notice how it has O and H?
Could it have been cosine too?
Yes, if you had done, yeah, because this angle is also 45 degrees.
And it was given to.
Yes. Oh, did it say angle A? No.
I thought.
But it would be 45. I mean, if you found it, you could find it using 180 degrees. Okay, so we have the sine of 45 degrees equals, what's the opposite side? 5 over Y. I see what you're saying now. If we had used this one being 5. Yeah. Yes. All right. So cross multiply. Whoa. Did not mean to do that. You get Y times the sine of 45. I set it up this way for a purpose. And so what are we going to have to do here? Divide by, yes. So it's Y equals 5 divided by the sine of 45. So we'll just type that in. 5 divided by the sine of 45. And again, we're going to use 3 decimals, just like everything else. What'd you get?
7.071.
So I got 2. Anybody get something different, you may come look at it. Okay. So this is approximately 7.071. Okay. This says multiply CB by the square root of 2. So CB times the square root of 2. What was CB? 5. So in your calculator, take 5 times the square root button is that blue right above the x squared button. So you'll have to hit second square root of 2. Let me know if you can't find it. It's the blue square root right above the x squared. You'll hit second x squared. What do we get?
It's the same as the
Same
hypotenuse.
thing. Just ring any bells from geometry. It's okay if it doesn't. Just like, no. Okay. That's okay. All right. Let's move on. The next triangle. Okay. It tells us if AC equals 5, find the length of CB. So AC is 5, length of CB. So I'm going to call that X. Donna, what kind of sides do I have here? Like opposite, hypotenuse, adjacent? 5 is the opposite. That is hypotenuse. Yeah. So the hypotenuse is always across from the right angle, so that leaves X as the adjacent. Good. So Tyler, which trig function includes opposite and adjacent?
Tangent.
Yes. So Katoa. O and A is opposite and adjacent. So that's tangent. Good. So we have the tangent. What's the angle measure? 30. Equals what over what, Jenna?
5 over X.
Yes. Opposite over adjacent. So we cross multiply. X times the tangent of 30 equals 5. Divide both sides by the tangent of 30. Oops. No, I didn't do that right. What did you end up with, Gisela?
8.660.
Yep. You may not get that, you may come look at it. All right. So on the next one, it says AC is 5. We're trying to find the length of AB. So AB I'll call Y. So we're looking at this side and this side. Which side is Y, Berkeley? As in opposite, adjacent, hypotenuse. The hypotenuse. So Berkeley, which trig function uses these two pink sides? Yeah, opposite and hypotenuse is sine. So we're going to use sine. But yes, you could have used the 8.660 to use the other one. It's just, if you can keep from using a rounded answer to find the next one, it's better not to. So, we said that was sine. So the sine of 30 degrees equals, it was opposite over hypotenuse. Let's see here. Shelby, what's opposite over hypotenuse?
Opposite over hypotenuse is sine.
Yes. And then which numbers am I going to plug in for opposite over hypotenuse?
5.
Say that. 5 over y. Good. Okay, cross multiply. Y times the sine of 30 equals 5. Divide by the sine of 30. Jenna, what'd you get?
10.
Yes. Okay, it says multiply AC by the square root of 3. So AC we found to be 5. So if we take 5 times the square root of 3, who you get? Anybody? Yeah, notice. And then multiplying AC, which is 5, times 2. We can do that one in our head. What's that one? That's 10. Notice. Oh, I don't know why that should be exactly 10.
Isn't that like, I forgot how you know where to place a number, but like a shortcut for
Yes, yes. Both of these angles are shortcuts. And then we just figured out what they were. And they are actually on the next page. We have two special right triangles, is what they were called back in geometry. The 45, 45, 90, which is an isosceles right triangle. Does anybody remember what isosceles means?
There are two congruent sides.
Yeah, two sides are the same. Let me make that not quite so. Let me pretend. So if you have a 90-degree angle and one of the angles is 45, then we know that the other angle has to be 45 because they all have to add up to equal 180. So it's a 45, 45, 90. And if you read it, it says the lengths of the two legs opposite the 45-degree angles are congruent. Well, it's isosceles. That means two sides are the same. And then it says the length of the hypotenuse is the length of a leg multiplied by the square root of 2. So it's A times the square root of 2. The way you probably saw this, I don't know for sure, but the way I used to always is 1 square root of 2. You do it like that. So instead of going through all that we just did, especially if this was like a non-calculator part of the test, then if you knew it was an isosceles right triangle, you could just take whatever the side was and multiply it by the square root of 2 to get the hypotenuse. Or if you have the hypotenuse, divide it by the square root of 2 to get the leg. 30, 60, 90 triangle. We have, the way we wrote it was 1 square root of 3 and 2. The side across from the 30-degree angle is the short side. To find the side across from the square root of 60, you just take the short side and times it by the square root of 3. And to find the hypotenuse, you just take the short side and you multiply it by 2. So those were shortcuts. And those are special right triangles that you need to know. Okay. To solve a triangle, we find all the missing sides and all the missing angles. So if I ask you to solve a triangle, that means you find all the missing parts. And we're going to practice this stuff with the trig ratios to solve each of the following right triangles. So I'm just going to make this a little bit bigger. I'm going to label everything we have. We know that AC is 11. We know that CB is 16. We don't know BC.